Good afternoon, everybody. In the today's class of this robotics, we'll be dealing with the homogeneous transformations and the two of the combined or compound transformations in the three-dimensional coordinate system. And later on, operation of these robots in different conditions of kinematics. Initially, we'll review the summary related to the three-dimensional coordinate system, the formulations that we have, the derivation part in the yesterday's class, the rotation of link that needs to take place on a particular joint with about z-axis coordinate system leads to then formula cos theta minus sin theta cos theta, and 0, 0, 1 is of the 2D frame. If it all is a 3D frame, 0, 0, 0, 1, and next here will be 1, imposing of three-dimensional matrix system. Simultaneously, in the case of this, rotation happened towards the y and rotation towards the x. The compound transformations, comparing the rotation, translation, and furtherly rotation, and comparing the end effector position with respect to the initial condition, and after the transformation there is final condition with respect to the base part. So the reference frames with respect to the C related to the base part, frame base is related to the frame A. So there will be a linkage between one working hesitation with respect to one joint to another joint. We are aware that if the link 1 has been changed, that the supporting links or the dependent links will be calling link 2, link 3, and end effector will also changes its position. Obviously, if link 2 changes, there will not be any change in the case of this link 1, but link 2, which is holding this link 3 and end effector will changes its positions. Vice versa, if the link 3 has been existing any of the transformation, either the sliding or rotation, consequently this link 1 and link 2 will be in halting position. Only the end effector with respect to the link 3 will be changing its position, and so that the changes in the case of this rotational factors and translational factors with respect to the coordinate systems and with respect to the inclination, if there is any changes towards the frame with respect to the coordinate frame, either from xy to the yz or zx plane, or from yz plane to the xy or xz plane, will be considering depending upon the value of theta. Just we have been seen in the yesterday's class related to an example problem. So we need to obtain the end effector position after the different transformations, which includes both sliding actions and rotating actions and even the revolutionary actions. that's about to rotate or revolute with respect to an axis system, either x-axis or y-axis or z-axis. We have framed three different formulations based upon the matrices with the trigonometrical values. So upon substituting the theta value over there, we'll be having the change in its vector from its initial position to the final positions after getting the transformations. Coming to the point of this inverting a transformation matrix, it's clearly related to the inverse kinematics. So initially it's an forward kinematics compound transformations. The point of this end effector, which is existing at the starting stage, get transferred by sliding its actions. The first one is a translatory motion. Second thing, it is rotated with respect to a particular inclination. So this is the first value, that is theta, let it be of 30 degrees, and this 30 degrees to additional more 60 degrees, it is existing with respect to the last coordinate system. That means a rotation of additionally 30 degrees has been commenced. So theta 1 plus theta 2 also came into existence here in the frame number C, if you have clearly observed. And obtaining the x, y, z values of this end effector with respect to the base coordinate system will indicates the position of the end effector after the transformations. So it is related to complete extension mode of end effector, either in translatory motion and rotatory motion. Here, the inverting kinematics clearly specifies related to the contraction of agitation. So same, if reverse in nature, if the links has been happened, what will be the position of the end effector? Look at verify minus 30 degrees. So you need to come back to the original position from frame C to frame B, and from frame B to the frame A, or with respect to the coordinate system changes. Here from 60 degrees to 30 degrees, that is minus theta need to be happen, and negative translation to be taken if it has been happened while it's forward kinematics towards x, y, z, and simultaneously in the three coordinate systems it need to be retracted. That will be calling extension stroke and contraction stroke. So here the negative theta 30, and hence maintaining of 30 degrees, back again to the frame B, that is sliding back and attaining the original position of the end effector. And when compared to the base frame, the end effector position should be as specified in the vector 1. So it is the basic phenomena need to be taken place in the case of inverting a transformation matrix. Nothing but back position of the either of the rotation, revolution, and prismatic moments. That is a negative moment, that is or contraction of motion. Let's have a clear-cut look related to the forward kinematics and inverse kinematics. The forward kinematics is used to determine the location of an end effector with respect to the reference coordinate frame. It leads with the study of geometrical motion of the end effector in three-dimensional coordinate system, which is an fixed universal coordinate system without the regards to the forces or moments that will cause the motion on the end effector due to the joints orientation or links extensions or contractions. And the environmental conditions need to be captured with respect to the channel of movements when it need to be commenced on each and every link. See the open chain manipulator kinematics. So in the space, the mechanisms. So here the mechanisms leads to the homogeneous transformations to the different links. Either it may be of the link 1 or link 2 or link 3. The mechanisms of a manipulator can be represented a kinematic chain. So the linkage of two different links leads to one joint. The motion that has been created on the link 2 based upon this link 1 leads to one transformation, that is rotation, for about a theta in any of the axes that has been specified, or as per the task it will be fixed out. The mechanism of manipulator is represented its links either by revolutor or prismatic positions. And that it consists an end with respect to the base, and we need to calculate the position of the end effector which is attached to the link 3 with respect to the base frame. This is the base frame, or it's on fixed axis. This is the link 1, this is the link 2, and link 3. End effector will be fixed out here. And if at all the rotation has been commenced here 30 degrees, there will be changing in the position of the end effector from this position to this position, and the position of the end effector will be here. And initially x1, y1, z1 will be like this, and after rotating of theta 30 degrees, this is the end effector values x2, y2, z2. Simultaneously, if there is any change in the link 2, obviously end effector position from here to it will be getting changed towards this position. Just imagine related to this. Even if the link 2 has been changed its position, link 3 will be changing, and the end effector which is attached to the link 3 is also changes its position. So initially link 3 is getting changed to 30 degrees. From here to end effector position will be changing to here. And after link 2 is furtherly changing its theta, that is for example here to theta 30 degrees, and furtherly the end effector already it has been having for example it's on 15 degrees. Let's consider with respect to the base frame. This is the base frame, the parallel agitation, just allow assume here parallel condition 15 degrees, and a 30 degrees orientation has been commenced. So 15 plus 30, 45 degrees will be taking place. The end effector position or vector 1, and here the position vector 2, and if the link 2 changes about 30 degrees, so 45 plus 30, 75 degrees centigrades. Sorry, 75 degrees, right? The orientation, and hence from the vector to coordinate units, geometrical units to furtherly vector 3 geometrical units will be getting changed. which changes the values of X, Y, and Z system. And this is a chain linkage that gets deferred with respect to the moments of the links. When the same kinematic chain has been assumed in a closed environment, as the movement should be confined within the particular environment, or let us say in our robotics language, a work volume within the fixed work volume. Let us call it's a fixed work volume. And we all aware that the fixed work volume is nothing but the end effector, which will be having its movements surrounding of its working environment when it is in completely extended position. So the kinematic forward kinematic position already taken, and in and around the service surrounding of its fixed axis, the working phenomena will be happening and performing the tasks at different places. And this closed kinematic chain can be equated with respect to the coordinate system frame of cylindrical coordinate system, or else the spherical coordinate system, to which the operating axis will be fixed. And hence, in the closed kinematic chain, it's a difficult to manufacture. Even analysis has to take into the statistics, and different constraints need to be followed with respect to the another other supporting links also, or depending links also. Hence, the synthesis of closed kinematic mechanisms are very much difficult in the fabrication point of view. But what's the basic difference between this normal kinematics and differential kinematics? So normal kinematics, it clearly specifies the analytical relationship between the joint positions and the end effector positions and its orientations. But this differential kinematics describes the analytical relationship between joint motion and end effector motion in terms of velocities. So the movement at what speed per unit time the entire actions are being taking place with respect to the end effector due to the rotations or translatory motions that are being creating on the joints. So hence the joint motions that are being taking place. Try to understand the clear cut difference between the normal kinematics and the differential kinematics. In the case of this kinematics, it specifies the relationship between the joint positions upon its orientation, and it compares with and specifies the end effector position with respect to the joint positions. But in the case of differential kinematics, it specifies the relationship between the joint motion, how much degrees it need to be rotated or revoluted, how much units it should be slided in a prismatic type of joint in either of the axes, either of the x, positive or negative of x, comma y, comma z, and compares with respect to the end effector motion in terms of its velocities. See the coordinate frames, how the changes will be taking place. There's the camera frame, the working environment of entire the pick and place kind of robot actions will be captured here. comparing the global coordinate system with respect to the base fixing alignment is the link 1, which is having a pivot joint with respect to link 1 with respect to link 2. It can exercise the rotary motion, and link 3, which is supported to link 2, having the pivot joint and furtherly exercising the rotatory position only at the fixed axis, and the end effector has been fixed here. The main goal is to take the ball and placing it somewhere else. So it leads a jointal movements of the fixed axis. All right, at the fixed axis with the change of its orientation about theta. So positive theta or negative theta. Here, link 3, which is holding this end effector, will slides at this pivot joint. Let it be the joint 1 and let it be the joint 2. Slides towards the positive theta and negative theta. Obviously, in the link 2, here is the pivot joint with respect to the link 1. It also slides over this joint, but the changes in the end effector also will be taking place with respect to this link 3 also. So upon complete negative theta, it may not able to hold by this end effector for picking up the ball. And furtherly, the negative theta in the link 1 link 2 also need to be taken place and need to grasp the ball from this position. And obviously, positive theta will raise the holded object towards the upward direction when the theta in the positive direction commences both in link 2 and link 3. And hence the frame of positions is also getting changed due to its rotational aspects. That's the main motto is to describe. And here, the two frames, which is having a kinematic relationship, may be basically a translation or a rotation. This relationship upon our 3D analysis, that is homogeneous transformation matrix, will be approaching. See, consideration of 3x3 rotational matrix of coordinate axis, that is x comma y comma z, towards any of the one transformation or translation, and global scale units that 0, 0, and 1 is an identity, represent the identity matrix. Hence, the rotational matrix is orthogonal. So, rotational towards the translation and rotation leads to an 1 identification. There is 3 independent entries as per our Euler's angles. Observing the two basic joints here, revolute joint, which is having a pivot, the axis is fixed. This is the base joint for this, and this is the follower joint. Follower joints is depending on the base joint, which rotates with respect to the theta inclination towards the clockwise or counterclockwise direction. And the prismatic movement, the axis of direction will be sliding over this base. Either it may be of positive x or negative x, positive y or negative y, or positive z or negative z. And in the three-dimensional alignment, The fixation of links will be based on the work parametric sources, that is based on the environment of the work, whether it need to be done in an open channel or a closed environment, and the links will be designed with respect to a particular joints, and examining the end effector position, whether the targeted work is being done by it or not. That's an open kinematic chain, which leads to an joint 1 change, and this is the link 1, and this is joint I plus 1, this is the joint I plus 1. If otherly any of the joint that is being holding at this range also. So see, this is the one joint and this is the one joint. So upon slice, comparing only the jointal positions, and based upon this jointal positions, the work need to be characterized. The joint I is the link I and joint I plus 1, and this link I plus 1 actually, where the end effector will be attached to it. And examining the changes in the working frames, and if furtherly changes happens in the work frames, the end effector position also. Coming to the direct versus inverse kinematics. So forward kinematics and inverse kinematics. The joint relations, either of the rotations or revolutions or translations for the robot arm, as per the task, specifies what the orientation and position of the end effector is towards only the positive axis. Here the inverse kinematics given is desired end effector position and its orientation, particularly with respect to the task for the joint rotations and orientations to achieve. So contractionary positions and negative theta or negative phi values should support the task to be finished. So upon extension, the object which need to be grasped will be holded by the end effector. If the example has been considered like this, the extended position, link 1 position, link 2 position, link 3 position, and end effector position. Upon complete extension and rotation, the object will hold by the end effector, and simultaneously the contraction negative theta, and this sliding towards the negative axis leads to again the original position and unloading the object, or else here picking the object and upon extension placing the object at the targeted point and obviously coming back to the original place. This clearly specifies the inverse kinematics mechanism is. And here the robot controller must solve a set of non-linear simultaneous algebraic equations. So you need to solve this. Why you need to solve this? In the sense, there will be the sources of these problems, because the nonlinear equations will be simultaneously generating, leads to an theta deflections in its coordinate frames, towards the sine and cos in its rotational matrices, and existence of multiple solutions, the possible non-existence of a solution and singularities will be clearly found out in the case of this inverse kinematics. So one thing it is very much clear that it is confined in the Cartesian coordinate system, and joint spaces and actuator spaces proceeds furtherly relates to the kinematics, that is creating the motion for the first step and having the dynamic controls towards its mechanisms. If the considering a live use of example for holding or commencing the works at the external range for fitting sections, real hexamode is the analyzer and fitting section, which leads to examine the multitask in and around it. As the robotic arm will be getting extended from the base frame, identifying the defects. If there is any non-linear conditions taken place, obviously it will completely extend it to its position to the targeted point and tightening with respect to the fluids. We all aware that end effect are consisting of two types, that is grippers and tools. So for fitting and opening conditions, the tools plays a major role. Here on identification, the tools when process the machinability characterizations at demo principles. And obviously we'll be coming to the contracted position back again for this demo movement towards the forward and backward direction. And this is the basic controller unit that guides to happen these sources of problems identification, that is nonlinear equations by the controller, and how to solve the set of these nonlinear solutions simultaneously. So spontaneously it should be responded and have to commence the process for solving. So this is the best example of real hexa mode, which identifies the unsecured parts which are existing within the industry and holding the objects or picking the objects from one place to another place, heaviest objects. If it was the tools are being utilized, it leads to the fixing of the parts clearly with tight fixation. This is the best example of forward and inverse kinematism. There's a real hexa mode. There is the clear-cut picture of a movement of different links and working agitation towards the forward kinematism and towards the contraction position of the links indeed to move this demo controller from one place to the another place. And the movement creates the jointal variations or changes in the position of the joints, which leads to the changing in the vector positions of the end effector. And that leads to two different functionalities in the case of prismatism and another two different functionalities related to the rotational revolutionary concepts. And hence, four basic rules will be taking place. First one is an prismatic system. Second one, it is a rotational system towards the theta. Upon rotations, the planar position will be shifted from one plane to the another plane. That is a shifting distance d. And finally, at what range it has been shifted with respect to the inclination or orientation. That is with respect to the phi. When it has been compared This rotations and prismatic movements with respect to the base frame. So these are the four parameters specified by the Dinavit-Hartenberg scientist. We need to examine the end-effector position upon this orientation and rotation and prismatic sliding actions commencing in the industrial robots with respect to the base frame. Those are named as DH parameters, Dinavit-Hartenberg principles. This is the Dinavit-Hartenberg principles. So hence the assumptions that the robot may be made of successive joints and links. Joints may be either of the prismatic or revoluting joints. These joints may be in order of the sequence, maybe in a plane, in any of the plane. Links may be of the length including 0, and it may be twisted or bended that changes to any plane as you've been discussed. The formulation that I minus 1 link to I link translation, and here the translation involves both the prismatic joints as well as the revolutory joints or rotatory joints, leads to an rotation or revolution of minus 1 link to the I link, and the orientation related to with respect to the I minus 1 link to the I link. And this is the unitary matrix considering in the three-dimensional coordinate system x, y, z with respect to base frame. Base frame is having the origin position 0, 0, 0 is the origin position and unitary matrix. And hence entire the transformations that has been considered will be identified by utilizing this formula. And here the rotation or revolution considerations or translatory motions will be specified in the different coordinate systems x, y, z. All right, and this I may be of 1, 2, 3 if n number of this I relates to n number of links. If I is equal to 1, will be having the one link of containing robot with respect to base. So if I is equal to 2, we are having two different links based on one base, and three different links with respect to base frame. So base frame in the sense here origin position 0, 0, 0, and depending upon this I value will be identifying the different kinds of links and its extension positions based upon its translations, that is sliding motions or orientations or rotatory motions, leads to forward kinematics. And the similar contraction position with different identification factors upon simultaneous solving generates the inward kinematism. That is it, coming back to its original position after the task finishing. That will be clearly seeing in the next class. TH parameters. Thank you.